Hello everyone, myself Shivam Bajaj, and in this video I'll be summarizing how browser works and how learning how browser works help you as a developer. So quick before we start a quick note what you can expect in this video. In this video I'll give you a high overview of how browser works, what happens when a user makes a request for a URL, and then how it got converted into an actual page. A high overview as this is a summary video. Then I'll walk through the references I have used while learning about how browser works. And then at the last, some few open questions like which will help me, which can help you, me, and anybody as a developer. And later I'll work on those questions or open-end questions and try to execute them. So let us start. So how does a browser works? So this is the basic structure of the overview of a browser. As you can see, each browser has a user interface, then its own engine, then a rendering engine, and few other components such as UI backend, networking, etc. Okay, what do I want to display by this structure of the overview is this is how a typical browser look like, irrespective of being a Google Chrome, Safari, or the Firefox. These three the most popular and the common web browsers out there. All of these share the similar or have these structures irrespective of their internal details and implementations. Each one will have a UI, will have a few common, even in the UI, they will have few common points such as the URL bar where a user will enter the URL of a website. Then the browser own engine, which using that browser computes the logic and does the backend work for the user. Then the rendering engine, using this rendering engine, browser actually renders the website on the UI for the user, and few other components such as data persistence, which includes our internal storage, local SQL index DB, session storage, cookies, then the UII backend, which is used to compute the UI layout, then JavaScript interpreter or the JavaScript engine out there, which which is used to parse and execute the JavaScript code, and then the networking components. So this is a highly overview of how a browser looks like and what component does it has. It will be common across all browsers. Now, moving to next, the browser workflow or how does a browser works. So as we can see on the screen, we get the HTML. HTML and the CSS are the starting point of our execution of a browser. How it converts an URL into a web address. I will get into that phase as well when we enter a URL and how it get converted into a page. Before that, I'll give you a highly overview. So what will happen here? A user will hit a URL, let's say example.com. Then browser will make a request to get the example.com from the server. And then after getting the response, in the response, the browser will get the HTML, CSS, and the included JavaScript files. So what browser will do? Browser will first go through the HTML file, the index.html file. It will parse that file. By parsing here, what I mean is it will take the HTML response and convert into a format which is machine understandable, or convert into a language which is machine or the browser understandable and as well executable. So that format of course so that thing will happen in the parsing phase. The same thing will happen for the CSS files if there are any. They will get converted. Okay, the browser will get the CSS files. It will parse the CSS files, the rules, and it will parse the CSS rules and convert it into a language which is browser or the machine understandable. By parsing here for the both HTML, CSS, or even for the JavaScript, doesn't only means to convert it to a language which is machine understandable. It also includes the phase where they validates. Okay, this HTML is valid, or this CSS is valid, this JavaScript is valid. So they actually validates. You might have observed, okay, browser will tell you, okay, hey, this CSS rule is wrong, or this CSS can't be applied, or there is some wrong in your HTML code, or in the CS, or not in the HTML code, in the JavaScript code. So those identifications, validations of the syntax and the rules, what a language can do, all all those things are done in the parsing phase or the parsing step. Once parsing is done, the HTML content or the HTML response or the parsed HTML response is converted into a DOM tree. So what is DOM here? You might wonder. DOM is document object model. It is the markup or the representation of HTML for the browser internal use as well as for the outside environment such as JavaScript. So browser uses this DOM to communicate, but to lay out on the screen. And also the JavaScript uses a DOM tree to manipulate the HTML, what we see on the screen. So the famous thing on the quick analogy is for the React.js. So what happens? The browser gives the HTML DOM is supplied to the React.js. There inside the React.js, the JavaScript code uses then the JavaScript uses this DOM to execute the written JavaScript code by the author or the developer. Then it manipulates a DOM starting from the root. So DOM is nothing but T structure, okay, which is the markup or the representation of the HTML response or the HTML which is received from the server. This is done in why it is created into DOM or why not why not some other structure? Why tree structure one is that it is relatively easier to work with tree structure in Traverse when there's a lots of HTML and other content related to it as compared to some other structure which can be, let's suppose, a graph. It doesn't hold that info. Okay, I have less info on why DOM is of tree structure. Why not some other structure? I'll get those info and get back to you guys. So going to the next, once CSS style sheets are passed, they are also converted into tree-like structure, which is called CSS DOM. Okay, these style rules also, as I said earlier, they will convert it into CSS DOM. It is also a document CSS document object model. It is in a T3 format where all the rules are laid out. Okay, these two things, the DOM tree and the CSS DOM tree process only happens post all rules are validated and they are right against the markup or the syntax and the rules of the language. If there is any mismatch there, then an error will be thrown out. This statement which I just said now is true valid for the both CSS and JavaScript, but not in case of HTML. In case of HTML, there is a different parser which says okay, where the browser says okay, the HTML parser says okay, I am error tolerance free parser. So it will let you pass through the errors. It won't stop you there. So now coming to the third step, DOM tree and the CSS style rules or the CSS DOM. So in this third step, both the DOM tree and the CSS DOM are attached together and a new tree is created which is called render tree. They both are linked up together. They are post creation, they are linked up together so that okay browser can proceed on the process of displaying the UI to the user. So once both are linked up together, they are called the render tree. Now comes the phase where browser will start rendering the UI on the screen. So first thing which happens here is the layouting. Okay. So what do I mean by layouting here? Here, as the name implies, here browser tries to create a layer or a structure where they just laid out the elements in the boxes. Yeah, right, the boxes. We have been thought about, okay, think of each element as a box. This phase or this step is where browser lays out each element as boxes on the screen for the user in the pixels. Yes, browser uses the pixels, so it's a viewport dependent devices. So browser lay out them according to the pixels. Okay. Once this layout process is done, it will move to the next process, which is painting. Okay. So what happens in the painting process is their layers are composed. Like once we have laid out the structure, okay, now next step process comes is okay, how to apply those CSS rules, those all things, and the positioning things all get applied on the painting process, on the painting step. Once that is done, combination of this layout and painting, once this is done, then the UI is actually laid out on the screen or displayed on the screen. So let me summarize these things here. Layout and painting has layout and painting combined has three to more four substeps as we get into it. So I'll combine few. What will happen? We'll get the both the trees, the DOM and the CSS tree. Okay. We'll combine them, call them a render tree. Suppose that layout and painting come into play. Once this is done, layout and painting are the repeatable and recursive process. Each time there's a change in the dimensions, width, or the locations, then the layout of painting will re-happen again. There might be cases there might not thing or layer, some layers of the layout of painting might not happen. Okay, let's say we have an image whose width is not given upfront in the layout state, so a placeholder will be left for that image. Then later, after that image is loaded and we got the image, we'll get the image width and the height. Now again the layout step has to be repeated. This repetition of the layout step is called in some language re-rendering. For some browser rendering engines it is called re-rendering and some called reflow. In terms of Firefox, where rendering engine browser rendering is called reflow, and when it comes to WebKit, I guess it is called re-rendering. So this will happen again. So again, coming back to where I left off. So layout and painting includes okay laying out the each of the elements on the device screen or the browser or the user screen where the browser is currently running. So how the layout they are layout at first they will be laid out as boxes. Each of them will be given a width and height, and they will be laid out in the recursive manner. Each child inside their parent. Once this laying out is done, calculating their width and height, the portion, the content, everything, then painting comes okay where they position them according to their positioning. Once what we are first calculating the width aside, positioning, then applying of the CSS rules. And one or more step here might be there. Once these steps are done, then the UI is visible to the user. Now, one thing I like to add here, okay, HTML parsing and execution doesn't stop whether the CSS file is being loaded or not, but the JavaScript do stops or may stop because JavaScript might be dependent on the CSS rules to get the DOM element. So for that, CSS rules have to CSS style sheets have to parse and execute it first before JavaScript gets there. And in today's browser, we have a preload scanning feature where browser what does they try to identify okay assets which can be loaded earlier while HTML parsing is going on, and they will load them first. Oh, sorry, my mistakenly I said they will download them parallelly while HTML code is getting executed. So soon as a browser reaches the page, okay, phase where it needs the image file, get the file instead of waiting for file to be downloaded and then waiting for the network response. Same for the JavaScript. But in case of JavaScript, or same for the CSS and the JavaScript, but in case of JavaScript, if that file has to be executed right there, then the browser has to hold or the stop the current HTML parsing and execution until it has to start with the JavaScript file. Yeah. So now once painting is done, the HTML page will be visible to the user. So any changes made from now onward will cause a cycle of layout and painting again, a reflow of layout and painting. Again, if a change is made to your DOM, then it will start again from the same phase, render tree, layout, painting, and all those steps. Same for the CSS as well. So, going to the next step. In the next slide, you will see a overview of how these things happens. Let's say we got the HTML. Okay, we parse the HTML and construct the DOM tree. Then we'll come to the step of render tree construction. The render tree, as I said earlier, is a combination of the DOM tree and the CSS DOM tree, where both the rules of HTML and CSS are combined together and tree is constructed using both trees. Then that tree is laid out on the screen with the position, width, and height, and everything. Okay, what will get what, how much width and height will get which box, and how has to be laid out on the screen. Okay, then comes the painting where the actual content is painted out using the CSS rules. If while doing this, if a user scrolls and some things happen, then again a reflow will happen and re-rendering will happen. Because they might have a browser has to recalculate. Going to next. Now, before we go to this walkthrough of references. So what do I mean by that? What I mean by this, I'll walk through you few references or the two references which I've used while understanding how browser works. First one is populating the page how browser works by MDN. They explain brilliantly like okay, what will happen when a user enters a URL, where it goes, where it went, and how browser resolve that request. And they in this article, MDN team has explained it briefly. They are given a good overview of how actual browser works. So I'll like I'll tell you what where they start. So if you come to this article and you start reading, in the overview section you will get to know okay what is actually they meant by performance and how performance and they what is actually they meant by performance and what performance meant for a user. One performance is which we are, as a developer expect, okay, our site has to be load fast, it has to be tactic. Another is perceived performance, which a user perceives. So there they give a very high overview, okay, what will happen when a user enters a URL and how it performs, how it perceives performance and how a developer perceives performance. It's a very highly overview of the performance thing where they tell okay browser is a single threaded and its latency how latency comes into play when it comes to the performance then the interaction how the interaction time is counted from the right from the first request. So it's all started with latency where they are trying to explain it starts with the network latency then it goes to the browser single thread then the navigation part. So here they start explaining, okay, how a user makes a request. User hits the URL. As I hit this URL, then this URL will come to browser as a request. Okay, browser will try to get its IP address through DNS at lookup. Once it's found the IP address, browser will reach to the server. Browser will ask for server, hey server, this is a request have been made by the client, my client or the user. Please give me the response. Now, before giving the response, this browser and the server will do a TCP handshake, TLS handshake. These all things have been explained here. You see, if you come to this part, you'll get to know okay, how TCP handshake happen. They are given a very highly overview of here. Good to know. Then TLS negotiation, what is TLS negotiation and what is HTTPS negotiation, or in short. Okay. Now coming back to this, once this is done, TCP handshake and the HTTPS TLS negotiation is done. Then they establish then the browser and server establish a connection. The server will return a browser response, which browser have asked for, and then they move on to next step. You can see, as I said earlier, a browser will make a request to a whole company and get the DNS of this requested URL. Then it goes to the site and asks for the response. These things, the navigation part won't be telling you how browser renders a page or how browser populates a page, but they will tell you, okay, they will teach you about what actually happens when browser requests a web page. What happens before? So it is good to know. Then comes the response part. Here, the main picture will start how browser populates a page. Browser will get the response. The response will be in HTML format, the HTML structure of the web page, along with HTML, CSS, and the JavaScript files, if any. There might not be JavaScript files there. There will be a link to a JavaScript file. Sorry, I said along with it. Okay, browser will get the response. Okay. If you come here, they will tell you okay, the time to first byte it has to be less than 14 KB and such, which is true. By far, you can get to know, and it is good for knowledge. We'll see later how we can okay utilize this knowledge which they have given here. Then coming in the response section, they have tried to explain okay how congestion code or TCP slow start happens, how server and browser communicate so that the packets or data have been sent doesn't get lost or the communication isn't too slow that okay the wait time for site to be to load or site to be interactive is way too much or even the user drops off. So they explain how they calculate on the fly what amount of data to be sent in what frequency and how much. So they have explained very good here, like they have explained it briefly in good here how they does. What they have explained here, the gist of here is okay, they will send a data packet. And if in the current window it is accepted and the browser acknowledges, okay, I have received this, then the server will start doubling the size of the data packet. If it doesn't get the response, the server will reduce by half each time it will get. So let's say if the first time server send the data packet of size 1, the next time it will send 2 and then 4. And if somehow server will get to know, okay, browser is not responding, is not acknowledging my request or response, then it will reduce 4 by 2, then it will becomes half of 4 is 2. So it will again reduce of packet size and it will be reduced by from 4 to 2. Then here in the response, going from response to the parsing section, here as I said earlier, they have explained how parsing happens, how a HTML response or HTML web page is converted into a DOM tree. Same for the CSS. They categorize them into critical rendering path. They explain, okay, how HTML parsing happens, how they are converted into tokens and such other things. How an HTML is converted to DOM tree. Before converting to DOM tree, it is parts where they are converted into tokens and validate, okay, this HTML parsing is correct. Even if HTML code is incorrect here, it will the browser will say, okay, for HTML I am tolerance free and I will allow you let you walk through. Why doing parsing here is that, okay, so that they can tell machine, okay, hey, this is the code and you can interpret it like this. So it's just a conversion of from human readable language to machine readable language parsing. So machine can understand it and execute the code. Then, as I said earlier about the preload scanner, he will try to load the asset as early as possible. So when as the browser reaches to them, it will be available to the browser. So they explain this thing here. Then the building of the CSS DOM tree and other processes, accessibility tree, JavaScript compilation. Okay. Post this is done. They have explained the parsing. Then this article comes into the render shift where you tell, okay, how these DOM trees, CSS tree, and combined JavaScript are rendered out. They have uh, they have said here that their rendering steps include style, layout, paint, and some case composition. By compositing, it means, as I said earlier, the layout and painting. These two steps will have layers of processes applied to them. So composition is nothing, just applying these layers of processes all together. Where one layer is calculating the position, one is size, another is trying to apply the styles, one is for stacking index. So all those layers combined together is called compositing. Sorry for the incorrect pronunciation in case I have done you. Then after all those steps, it will when they have explained styling, layout, painting, then the next one into compositing. These things done, then they come to okay, interactivity. From where the user can start interacting with the website, or user can see the website. They explained, okay, now we are all set. Now user can see the website and interact. Then they explain the TTI concept here. TTI is how long does it took from the first request which leads to a DNS lookup TSS connection to when the page is interactive. Interacting being the point is time after first print. Yeah, not after reflow re-rendering. And they say it has to be expected within the 50 milliseconds. If it is more than then it is bad for a website. So this much they explain this article and it is good for understanding how actual browser works. Now coming to the next. Like this is the meat and greet of the thing. Like web dev articles and how browser works. It will help you understand how browser works in detail in depth. I suggest you go in sequence, read that article first by MD and then come to this article because this is little long as compared to the previous one and costs you little more depth. Not fully depth, but just a little more depth compared to the MD1 article. Okay. It first they explain okay who are the authors. The Tali herself is Riley developer. She is the author here. She has done a they have explained okay she has done a good work in researching how browser actually works and how WebKit and those browser engines first. Then Paul Harris has summarized this for us. Okay, before I summarize this and then help you with okay what you can expect in this talk. The Google Chrome and the Safari uses a WebKit rendering engine, whereas Firefox uses a G-Core rendering engine. So these two are differences, and the the working of both the rendering is similar, but the internal implementation there and here and there they have minor differences how they apply the CSS rules or the parsing happens. Like introduction, the browser we will talk about the browser main functionality. Here they have given a brief overview, okay, what the browser main functionality and what is common in all the browsers. But the minimum you will get what is common in all the browsers and it is common across all the browser and you can think of it as standard across all the browser. It is not written somewhere, okay, these browser has to follow, but this is thing which is common across all browsers, and there are some specifications which are now mostly followed. Then, yeah, before I move on, the images I have shown in the slides have been taken from the web.dev, so credit goes to them. These images have been created by them. I have just to use those images to explain how browser works. So here they're given a browser high level structure, continuing with the previous one where they're explaining the browser main functionality. Now that was from a layman or end user point of view. Here they have given a high level, low level structure for a developer. Okay, they can understand okay how this is how my browser looks like internally. They can assume or they can visualize. Then they come into rendering engine. They explain here what is rendering engine and types of rendering engine. Then the main flow, which we have seen earlier, main flow examples. Here I have walk you guys through the WebKit rendering engine. They have also linked the diagram for or the sheet for the Mozilla GCOS rendering engine main flow. Pretty much they are same. You can see HTML parser, content sync, style sheet, CSS parser, style rules. Here content sync is where they merge the both HTML and CSS geometry. Then the content model and they have frame structure. Instead of using the layouting thing, they use a frame thing here, GCO engine. Then painting and display is common in the both. Reflow, as I said earlier, they use a re-rendering in GCO, the by Mozilla, they use a reflow as a name for re-rendering recalculations. Okay. Now, if you go there, now coming to the main flow here, they will explain you, okay, what is parser, what is a grammar, what is context-free grammar, why types of parsers in this section. I'm talking about the parsing general section and from it till the HTML parser, they explain you what is parser, types of parser, what is grammar, context-free grammar, and those things. Why these parser doesn't work for the HTML, why HTML does doesn't constitute with these parsers, but JavaScript and CSS falls under the JavaScript and CSS fall under these parser rules, but why not the HTML? So they explain this thing here. They'll walk through from here. Okay, translation, those things, generating parser ultimate. Then coming to HTML parsers, they explain okay what is how HTML parser works here and why it is not a context-free grammar. Okay. Then the type, the formal definition for defining HTML is document and definition, which is not in context-free grammar. They'll explain okay how HTML parser works and how it breaks down them into when it comes to parsing tokens from tokens. Okay, then uh, the code is validated first. Okay, I'll give you a brief overview of parsing here. What will happen? You get the HTML. uh, Here I'm not making it like okay it is for HTML. In general, I'm explaining what parsing will be. They'll get the HTML, parser will get the HTML. It will convert into tokens. It is a process where HTML code is converted to tokens or a language which is then used by the parsers to validate the syntax rules for a code. In case of HTML, for the HTML code, they'll try to validate okay whether they are right or wrong against the HTML rules or HTML syntax. Same we do for JavaScript, but in case of JavaScript, if there some rule doesn't match or there's syntax error post conversion into a tokens, then there comes to syntax validation. So parsing is like okay, first they'll get the code, they'll convert it to tokens, then syntax validation will happen. Okay. Once coming back to the HTML parser, they will convert it into tokens. They'll explain you okay why it is not in context-free grammar and those things. Then they'll come in tokenization. They try to give you a brief overview of tokenization algorithm here. Then actions when parsing is finished. Then tell you okay how browser error tolerance works. And seriously, they are little sarcastic here. In sarcasm, they explain. how people have written bad HTML code out there. So it will be fun to read these sarcasm paragraphs over here where they have explained a straight table, these things. This will be like, I enjoyed the part. Sarcasm and explaining, okay, how much browser puts effort or how much browser does work for us. Where they take our HTML code, even if it is wrong, they still let us go. Browser error tolerance is quite good. Previously, when they have also given a reference for XHTML where if some HTML code is wrong in terms of SSR or when we get the full HTML page from server, the browser used to tell the user, okay, this error is there, this line, those things will be getting displayed to the user. So they when they found out, okay, this is not cool and this is not nothing to show the user, so they went at, okay, browser error tolerance phase where they let the wrong HTML element parts and displayed instead of showing the error messages. But I do suggest read this browser error tolerance part. They have explained little sarcastically and good, like how much browsers engineers tolerate bad HTML code and what they have done in the parts to tolerate that. Then after this, they comes into CSS parsing. Here they explain on normal how CSS parser works and what they do. They convert those CSS code into tokens and validate against them the CSS language grammar or the syntax. If once this steps is done, they get into the order of processing scripts and style sheet. Here you will get mostly about, okay, speculative parsing, it doesn't modify the DOM. So here they have explained, which I said earlier, where they tell, okay, there might be a possibility that, okay, JavaScript might be expecting CSS. So why it is good to load CSS before the JavaScript? Because JavaScript might use CSS to manipulate the DOM. Then coming after this, they explain, okay, the render tree construction and how that happens. So again, this part is again important as it will help you to understand, okay, how browser actually breaks down the HTML response or the responses HTML, be it HTML, CSS, JavaScript response, and converts into in fully functional UI. They tell you how it breaks into multiple layers and how it gets then laid out or painted on the screen. Right from starting, okay, how style comparisons happens, what they do, how they calculate about the specificity, cascading styles, which rules applies, which comes over those all things have been explained in brief here. But a highly overview of those things have been given here with the rules and the examples, which will help you understand these things, which we use in our daily while we write code. Computing the style context using the rule tree, style sheet cascade order, what they tell, okay, when we tell, okay, what is important, what is not important, why specifically, such all things have been explained here. So it's a must read and this part shouldn't be skipped. Then coming to the layout, here they explain, okay, how layouting happens. It happens, the process it involves, the dirty bit system. It's a system where they mark, okay, this box, this layout, this box or this child component or this wall component, be it parent or child, anything has to be laid out again. So they use a dirty bit. They try to mark it, okay, it is dirty, and they explain, okay, how they do it globally and incremental layout, where they explain this is done in batches to save time and give us a reference. Okay, we should also be implementing our code in batches. Yeah. This, honestly speaking, this was also for me a little difficult to understand in the first go. I went to twice to this articles. I have understood bits of it. Still, I'm saying I need to read it again to understand and try to walk through it with the examples like how this happens using browser tools. Then they have gone through the layout process, how things are laid out with bit calculation, those things line breaking. Then comes to the painting global and the incremental. First they have done, then they're doing first they have done the global painting with the first initial rendering or the initial painting. Then they went to incremental painting where they do painting in batches instead of doing a small paint as I explained in the dirty bit system. Okay. Then coming to next, then they're showing Firefox, how Firefox does those things. the rendering engine, threads, event loop. Okay, then at last they try to explain the CSS visual model, the box positioning scheme. If you go through this layered, okay, box type positioning, layer positioning scheme. Okay, the CSS box model, difference between the both models positioning scheme. It is one of the layers of layout and painting steps. Okay, first is the width calculation, width and height calculation. Then the positioning, how it has to position in the normal, float, absolute, those things. Then the box types is in line with the block. Those it's again a sub layer of the layout and the painting steps, layout and the painting step. Okay, I'm combining these two together as for the better understandability. Then the positioning and the layered representation, the stacking along the z-axis. So there are four layers. First one is the box model calculation, then the box type, positioning, and layered representation. So this is how uh, these all are broken into separate layers. Then, as you've seen here in the MDN reference, they have used the word compositing. Compositing. Sorry for the wrong pronunciation. So this is nothing, just a compositing where they are putting it all together, all these layers together to to do the to to get done with the reflow, re-rendering or the repainting. Okay. Then at last they have just listed out the references they have used to understand how browser works. So as I said earlier, this lady has done a great work in understanding how browser works and laying and put her research out there, her research, how our browser works. So if you come to this article, you get the link to the actual article where she has wrote, okay, in depth about how browser works. And these are at last the translation. The image credits, as said earlier, again and again goes to the web.dev team. I've used their images, so credits goes to them. If you come, if you come to these two articles, you will get the in-depth knowledge of how actual browser works instead of like, okay, instead of just going through some random article and getting deep knowledge. Okay, there is some DOM tree, CSS for HTML to DOM conversion, CSS to DOM conversion. Then there's a layout, painting, done and reflow and re-rendering. They really get into that. You might, if you are new, someone has done or has less than 1 year experience. Let's not get into experience, but someone who's starting out. Let's say starting out, or have already started out with the coding programming. For them, this will really help them to understand, okay, how actually deep, how much browser has to do, how much work browser has to do. So these two articles are a great mix of learning how browser populates a web page or how browser works. Now going back to the video case, so next thing is open questions. Okay, here what do I mean by the open questions? So here I mean by open questions. First I'll get to what I mean by open question. So these are those questions which came into my mind. Like, why should I learn about how browser works? Like, why should I even care? Okay, the first obvious thing which came to my mind is being a developer who writes code for web. I should know how my codes are converted into a language or a format where machine understand and how to execute. That means understanding the machine on which my code executes. Okay, then the second thought came to mind. If I just had to know this, how, apart from the knowledge, how it will help me? Like, will it really help me to save some cost or effort or my teammates' effort or the other fellow developers' efforts? Or will it help me to really write a good code which is good in terms of performance? So, or even what does it teaches me about browser? Like, okay, how can I use this learning while I'm writing code consciously, consciously? Okay, if I'm writing code, I want to use okay what I learned so that it will so that results will be visible when the product is or when the application is available to the user. So these few questions which came to mind, I still I don't have answer to them. Like how will they help? How will they save cost? Learning me learning, or you or someone else learning how browser works, how will it help them apart from the obvious thing? Okay, you'll get to know how your code works on the machine on which it runs. Apart from this, how can I utilize learning how browser works? Can I use it while writing code? Can I use this to save cost or someone's effort? Or there is some tool or extensions or linkers or plugins which can help me. Okay, if you are writing code this way, this is wrong for the browsers. So these are the questions which I still not have answers to, and I will try to, and I will find the answer for these and update you guys. Yeah, and that's it. Thank you for bearing with me. And this is the end to the video on how browser works.